This is section 7.6, and this is on variation. All right, so we know that distance is equal to rate times time. So we're going to use this to kind of help us establish what direct and inverse variation are, okay? Direct variation means that as one thing increases, so does the other. So, for instance, time and distance vary directly or have a direct variation. So let's fix the rate at 60 miles per hour here. The time and the distance, you can see that as the time increases, as you're driving 60 miles per hour for 2 hours, you cover 120 miles. For 3 hours, you cover 180 miles. 4 hours, you cover 240 miles, and so on. So as this number increases, so does this number. And I'll put these off to the side just to show you how I got those numbers. Now, rate and time vary inversely. That means as one increases, the other one decreases. So in this case, because we want to compare rate and time, let's fix the distance of 300 miles. You can see that the faster you drive, the less time it takes you to get somewhere. And again, I put these little computations out here to show you how I got that, how I arrived at these numbers here. All right, let's do a formal definition here. A variable quantity y varies directly as a variable quantity x if there's a constant k such that y and x are some multiple. So some multiple times x is going to give you y. Direct variation is also called directly proportional, so Hawks uses those interchangeably. I just want to warn you of that. Now we could also have an inverse variation. Remember that says one increases, the other one decreases. This one has the formula y is equal to k divided by x. Now remember in the last example I showed you with the distance, rate, and time that we had the multiplication with the direct variation, and then the inverse variation we have this division. That's something really important to notice. Now inverse variation is also called inversely proportional, so just know that those are the same thing. So direct, multiply, inverse, divide. That's the big thing to remember here. Right, I know I'm going kind of fast. That's because I know you guys have access to the pause and rewind buttons here. All right, so if y varies directly as x, and y equals 3 when x equals 9, find y when x equals 7. We're going to use the same 3 steps every single time. Okay, so we're going to find the formula, and then we're going to use the first bit of given numbers to find k, and then we're going to use k in the second bit of given numbers to finish the problem. Now, finding the formula is all going to be in the wording. Because it says it varies directly, that's whispering sweet nothings into our ear, and it's telling us to multiply. So, my formula is y varies directly as x. So that varies directly right there is why I put that little multiplication dot. And I know it looks all big and fat and juicy and stuff, and that's just because I'm really accenting to that multiplication. You don't even technically have to write it. You can just smush the k and the x together and we know it's multiplication. Now use the first bit of information. That's this when y equals 3 and x equals 9. So we're going to use that. I put quotes around it because it was directly from the problem. We're going to use that to find k. We're going to plug these into this formula we just found. So that is an equation. You're going to solve that by dividing both sides by 9. So we get k is equal to 3/9, which simplifies to be 1/3. Don't stop. It feels like you might be done here, and that's a very common mistake. You are not done. Step 3 is to use this and that second bit of information up here to actually find y. Remember it says find y. That's not y, that's k. So step 3, we're going to still use that same formula from step 1. We're going to use k as 1/3 and the when x equals 7 to find y. Man, that's crooked. Sorry about that. All right, back to the formula. Y equals k that I just found times x is 7. 7 times 1/3 is 7/3. If you don't want to do that in your head, you can always use the calculator. You hit the n over d button here. We get 1/3 times 7 is 7/3. So you don't have to worry about doing that in head. All right. The next example. If y is directly proportional to the square of x, and y equals 80 when x equals 4, what is y when x equals 6? This directly proportional, once again, is whispering sweet nothings into your ear and telling you to multiply. So I just highlighted that so you could see that that's why I chose multiplication. Now notice there's a square on here. Why did I put a square on here? Because it told me to. It said the square of x. So just make sure you read these very carefully and that you just kind of know how to chunk this problem up into measurable, steps here. All right, so there's my first step. Second step, I'm going to use the first part, the y equals 80 when x equals 4. I'm going to plug in 80 for y, 4 for x. Don't forget to square that 4. That is a very common mistake. 4 squared is 16. You're going to divide both sides by 16. Now, even though this looks like a fraction, smells like a fraction, walks like a fraction, talks like a fraction, it is really division. If you put this in as a fraction in your calculator, it will simplify it to 5, or you can put it in as 80 divided by 16. This fraction bar also lives a double agent life as a division symbol. So we get k equals 5. You're not done yet. You still have step 3. Don't forget about it. Going back to this formula, as you can see, this formula is very important. If you get this formula wrong, then everything else is going to be wrong. So this is really super important to get this right. Now, plugging in that value of k, and then when x equals 6 into there for x, don't forget to square it. And you can just use the calculator for this. This is just a straight computation of 5 times 6 squared. No funny business, no equation solving here. You get 180. Example 3. This is an inversely proportional problem. If y is inversely proportional to x cubed, all right, we're going to use that first bit to give us the formula, and we know that that's telling us to divide. So check out the formula there. Why did I put a division symbol here? Because it told me to. It says y varies inversely, so that's the k over the x cubed. I'm going to use this next bit of information for step 2. I'm going to plug that 40 and 1/2 in and solve for k. So plugging in 40 and 1/2. This is a little tricky here. You can use your calculator. 1/2 all cubed is going to give you 1/8 because it's 1 times 1 times 1 and 2 times 2 times 2. Because this is dividing by 1/8, I multiplied both sides by 1/8 to solve that equation. So 1/8 times 40, you can use your calculator if you need. That's going to give you 5 for k. Remember, you're not done. It's really tempting to want to say that you're done here, but you're not. Step 3, we're going to use this value of k and the when x equals 1/3. Go back to this formula in step 1. So we got the k value, we've got this x is 1/3. Don't forget to cube it because that's part of our formula. So here we get 5 divided by 1/3 cubed. I realize that that looks like a big old fat hot mess. You can put this in your calculator 2 ways. I put in my calculator as division of 5 divided by 1/3 cubed. You could have put it in as a fraction within a fraction. That gets a little messy if you try to do it that way. So you hit the fraction bar, you have 5. On the bottom, you're going to need another fraction. So you'd have to hit a fraction again. So you get that 1/3. Ooh, I forgot to put the parentheses before it. So let me back up here. Now I'm going to get back over here. And then that's to the 3rd power. So you can kind of see how messy that got in there. It is certainly doable, but I feel like it's more room for mistake in there. So that's why I just changed the fraction into division and just did it as 5 divided by 1/3 cubed and got 135. Right. If a problem contains more than 2 variables and direct and or inverse variation, it's called a combined variation. That's not really anything magical, right? We're just combining some variations. So z varies directly as x squared and inversely as the square root of y. So using that to write our formula for this one. That's telling us to multiply, that's telling us to divide. So you can see how I tried to color code these. That green's not showing up all that well, but I tried. Second step, we're going to use this z equals 108 when x equals 6, y equals 4. So plugging all of that stuff into our step 1 formula. Now this you can use the calculator for if you need. This 6 squared over the square root of 4, that's 36 divided by 2, which is 18. And then you can divide both sides by 18 and you get 6 for k. Remember, you're not done. You got one more step to go. Okay, now we're going to use this value of k and the if x equals 4 and y equals 9 part of the original problem. That's why I put the quotes in there. So plugging in k from step 2, x is 4, y is 9. Don't forget the squared and the square root from the original formula. This is just one computation. Okay. You can do all this on the calculator at one time. So let's hit fraction. 6 times 4 squared over square root of 9. And you can see we get an answer of 32. If you're looking at my notes and you see these little fractions up here, this is just telling you how many pages there are total and what page I am on. I'm currently on page 7 out of 8. So that helps me keep track of, of time and how many pages I have left. Now, if a problem contains all direct variation, it has, more than 2 variables and it's all direct, it's said to be jointly, have a joint variation. Okay, so I do that because Hawks sometimes, instead of saying direct over and over again, it will say joint, varies jointly. So if Z varies jointly, so that's whispering sweet nothings to you, telling you to multiply. Multiply what? Well, the K, the X, and a Y squared. All right, so pause the video and see if you can write down the formula for this one. So the jointly tells you it's going to be multiplication, okay? So that's how I knew I'm going to multiply all these. And yeah, technically you don't need these dots. I'm just putting them in there for emphasis that, that they're there. You could just smush everything together. So incidentally, that smushing together of all those variables, it has a name. It's like a super sexy name. It's called juxtaposition. Y'all throw that down on the Scrabble board and then just walk away like a boss. So, okay. We're going to find K using that first bit of information. That's the Z is 63, X is 5, Y is 3. So plugging all that into this formula, we get 3 squared is 9 times 5 is 45. Divide both sides by 45. And I just got the decimal because it was a nice terminating decimal. You could have written it as a fraction as well. If it had been a messy decimal, like repeating or nasty or something, I wouldn't have written it as a decimal. All right, step 3, we're going to find Z, because why? Because it says find Z. We're going to use these two and the K that I just found and plug those into the original formula. You can just use the calculator for that, so I just made that little note out there so that you don't think that I did all that in my head. And that's all one big computation at one time. 1.4 times fraction 10 over 3, get out of the fraction, times 2 squared. Ooh, extra 2 in there by accident. All right, so we get 18.7. I rounded that. Now, if you want to change that to a fraction, this little key down here, this white key with the 2 black arrows, is your toggle key. So that's 56 over 3. Sometimes Hawks may ask you to round it. Like this is rounded to the nearest tenth. That's the first decimal place. If it asks for the fraction answer, then you just have to hit that toggle key. This key right here toggles back and forth between fraction and decimal. How do you know whether to write the answer as a fraction or a decimal? Just read the directions. Hawks will tell you. Okay, last up. Oh my goodness, that didn't flip gracefully at all. Oh well. The last one is a hot mess here. It looks like a hot mess, but it's not as bad as it looks. A lot of words though. The lifting force L in pounds exerted by the atmosphere on the wings of an airplane is related to the area and the velocity, and it gives us this formula. So here's what all this tells us so far. Okay, here's the TLDR here. Here's our step 1 done. If the lift is 9,600 pounds for a wing area of 120 square feet and velocity of 80 miles per hour, Okay, there's your first bit of information. There's your step 2 numbers. Step 1, done. Step 2, let's find K. We're going to plug in this for lift, so that's going in for L. We're solving for K, so we're going to leave it there. The area was 120 square feet. Don't square the 120. The unit is square feet, not the 120, okay? And the velocity is 80 miles per hour. This one is squared because the square is in the formula. Okay, now to do this, you're going to want to multiply that out on your calculator. And then to solve this equation, you're going to divide both sides by this number. So you're going to take 9,600 divided by whatever this 120 over 80 squared ends up being, and you get 0.125. Step 3, we're going to use the last bit of information. So find the lift. Okay, so we're finding L. We know what K is now. We just found it, so there's K. And it gives me a velocity of 100, so there's my velocity squared, 100 squared. Now here's the thing, it looks like it doesn't give you an area, but it does. It gives you a clue right here. It says the same plane. Because it's the same plane, the area of the wings is the same. All right, so you just need to grab the calculator, multiply all that out, and you should get 15,000. I encourage you to use the calculator along with me on these. You don't want to figure out on a test or a quiz that you're struggling to use the calculator. Make sure you're doing these along with me. Pause the video on examples and try to work ahead of me if you can. All right, so that concludes this section.